Welcome and hello. This is a HEC-RAS video exercise. And in this exercise, we're going to be dealing with 1D flood control, where we're going to identify the maximum release from an upstream reservoir that will not flood a downstream location. All right, so what I have on the screen here is my HEC-RAS. To give a little more detail on what the problem is this line right here. Find the maximum release from a reservoir to maintain a 0.5 meters of freeboard at the bottom end of that reach for a 2-year, 10-year, and 100-year storm event. Also, in this reach, we're going to have a lateral structure, which will convey flow out of the river, as well as lateral inflows. Those lateral inflows are shown in this table right here. So for the 2, 10, and 100-year storm at river station 400, lateral inflows will be entering the river at 20, 32, and 40 cms respectively. All right, let's go ahead and get started. What we have on the screen here is HEC-RAS. I'm going to start from the very beginning, so that involves going up to File, New Project, and then selecting the location we want to save this project. Save it into my project directory. I'll just call it exercise 43 and then click OK. All right, click OK. Now, right now I'm using US customary units. That's the default setting for me, but I'm actually going to be using metric units for this particular project. So I'm going to go to Options, Unit System, and then, okay, the geometric data editor disappeared on me, but just select System International Metric System and then click OK. All right, so that changed to SI units right here. That's good. We'll open up that geometric data editor and begin sketching out our river reach. I'm going to click river reach and then a single left click a few times just to give this river reach some curvature, and then a double left click at the bottom. I'll call it river A reach 1 and then click OK. All right, let's go ahead and define the cross-section data now for this river reach. Let's start by adding a new cross-section at the bottom of the reach first. Okay. I'm going to highlight and paste in the data I have prepared already. This is the cross-section data. The distance downstream is 0. I'm going to use some generic Manning's N values here for the left, center, and right Manning's roughness. And then the channel overbank is going to be at cross-section station 20 and 50. So click Apply Data, and then here is that cross-section. I'm going to add another cross-section at the top of the reach and then interpolate to provide some intermediate cross-sections without spending too much time on that. So Options, Copy Current Cross-Section. River station at the top of this reach is going to be, we'll say, 1,000 meters, and then click OK. So I need to also type in 1,000 right here for the distance to the next downstream cross-section. And then I want to increase the elevation, of course, because to make the water flow downstream, we'll go adjust elevation and then 2 meters. So that will result in a 0.2% slope. So we'll go ahead and close that cross-section editor box right now. And then to add the intermediate cross-sections, I'm going to go up to Tools, Cross-Section Interpolation within a reach. And then I'm just going to type in 100 meters right here and interpolate cross-sections and close. Here are our intermediate cross-sections. They're just created using linear interpolation, so pretty straightforward there. Next, I want to add a tributary at river station 400, and it's going to contribute 20 cms of flow. So we'll deal with the flow a little bit later, but what I want to do is zoom in right here on my, oops, okay, hold on. I want to modify the plot extents. So view and then set plot schematic. These numbers, they're not geo-referenced this model, so just know that I'm making a manual extension here so that I can see the elements in the model a little bit better. Okay, so now I can zoom in and pan a little bit easier. So I'm zoomed in here on river station 400 and 500. I'm going to click on river reach and just sketch in a tributary here. Double click. I'll give it the name Trib 1 or maybe Trib 400. It's at river station 400. And then reach 1 is fine. It's asking me, do I want to split this main river reach into 2 different parts? I'll say yes. So the downstream part is now going to assume river A reach 2 for its identifier, and then click OK. And now it's asking me for a name of the junction. I'm just going to call this J400 and click OK. All right, so we're all set up there. The existing cross sections for the main river reach are not changed, but I do need to provide some data for this tributaries cross-section data. So let's open up the cross-section editor once again. What we're looking at here is the cross section in the main river at river station 400, which is exactly what I want it to be for my tributary at the downstream end of the tributary where it intersects that junction. So I can just go options, copy current cross section, and then change the river to trib 400, and then set that river station equal to 0. All right, perfect. Now say for instance, I wanted this tributary to be just 100 meters, like the same thing from river station 400 to 500. Then what I could do is make a copy of 500 and set that to the upstream end of the tributary. So I'm going to select river A, river station 500. Now this time I'm going to, go options and then create a copy. This is going to be copied to tributary 400, reach 1, but at river station 100. That makes sense. All right, so we have the same slope in the tributary as the main river. Okay, so I can go ahead and close that up. We're good to go there. Next, I want to create a lateral structure which will allow flow to leave the river, and that's going to be further upstream at river station 800. So I've zoomed in on river station 800, this area here, and I'm going to click on lateral structure. And then for the river, I'm going to change that to river A, reach 1. I'm going to click on options, add lateral structure. I'm going to say the lateral structure is 20 meters long. So if it's centered on 800, then the upstream edge of it would be at 810. I'm going to type in 810 right here. And then the headwater position is going to be leaving over the right overbank. The water is going to be leaving out of the system. I'm not going to try to keep track of that water. And then weir and embankment. This is where we define the geometry of that lateral structure. Now I want the invert of the lateral structure to be beneath the overbank. So let's check out the cross section at river station 800. And here we have the invert of about 43.5, and then this overbank elevation is at about 46.5. Yeah, 46.6, 43.6. Let's go ahead and make the invert of the lateral structure to be 45.0. So I just wanted to check in on that. So back to the lateral structure station elevation data. I'm going to paste this data in here. This is the geometry. It starts at 49 and then goes down to 45, and that's going to be 10 meters wide. Okay, a few other things I need to put in here is the weir width. We'll say it's 3 meters, broad crested weir. And then down here, the distance to the next upstream cross section, that'd be 900 minus 810 or 90 meters. Okay, so that should update. Okay, there it is. There's my lateral structure. So anyway, we're going to have water entering the reach up here, which is going to be our reservoir release. Some of that water could very possibly leave through the lateral structure. Further downstream, we're going to have a constant 20 cms of water entering the river. And then finally down here at river station 0, this is where we want to make sure that the water surface elevation does not exceed the freeboard allowance of 0.5 meters. Let me select the cross section here, reach 2, river station 0. And then the overbank is at 45 meters right here, which means the maximum allowable water surface elevation would be 44.5. All right, so that's it for the geometry. Let's go ahead and define the hydraulic data, run the model, and start looking at some results. So I'm going to save this geometry as just a base file here. I'm not going to be changing it at all. Save geometry data. We'll just call it base and OK. We don't need to see that anymore. I'm going to click on my unsteady flow data right here. I can also access that by going up to edit unsteady flow data. And then here are the boundary conditions we need to provide. The downstream boundary condition right here at river station 0, I'm just going to call that normal depth and then use the slope of 0.2% and then click OK. All right, at the upstream end, this tributary, I know that that's going to be a constant 20 cms because I'm currently focusing on the 2-year return event for the design storm. So I'll go ahead and click on that, click on flow hydrograph. I don't need to enter hourly data, but I am going to run a 24-hour simulation. So let's just go ahead and switch this to day. This is going to be constant flow. I was going to run this using a steady flow simulation, but I ran into some issues that I couldn't get around. So that's why I'm doing it this way. And then also why you're going to be seeing some constant flow values right here. Okay, I'll use the simulation time, so it'll start at the same time as the simulation. Click OK. And then finally, the upstream boundary condition right here at river station 1000. We'll go ahead and define that as a constant flow hydrograph once again. Select 1 day. This is going to be the decision variable. This is going to be basically what is the constant release from the reservoir into the reach we're allowed to get away with. So this is the value we're going to be returning to and changing for each iteration. I'm going to go ahead and start that at 40. So let's put 40 a few places and then click OK. That's 40 CMS. So let's save unsteady flow data. Call that base. Okay. We can close that. Let's go ahead and open up our unsteady flow analysis. We're going to be using our geometry file called base, unsteady flow file called base. Now, typically, I may want to create multiple unsteady flow files and multiple plans. That way, the results could be saved and I could compare them in a plot. I'm not going to do that for this exercise, just trying to keep things simple. And I'm going to reuse the exact same plan file and unsteady flow file by updating and saving over new values for each iteration. Okay, so I'm going to check on some checkboxes here for geometry preprocessor, unsteady flow simulation, and post-processor because we want to see those results. I'm going to go ahead and save the plan here. Just use the word base again. And then it's going to be a 24-hour simulation. So for the 24 hours, it doesn't really matter which day. I'll just say it's the first day of the year 2020 and start at the beginning of the day. Okay. Also, if I want to add a warm-up period, I could say what minute, so that'd be 1 hour. And then file and save. All right, let's go ahead and click compute and see what happens. So the results are in. It took 3 seconds there. Let's go ahead and take a look at those results now. So I'm going to go up to view and cross section. And already it's identified this bottommost cross section at River Station 0 as the one I'm interested in. The water surface elevation looks to be just right around 44. And remember, we can go up to 44.5 meters because we have an allowance of 0.5 meters of freeboard. So what this tells me is the flow rate through here is going to be nearly 60 CMS, maybe a little bit less if any water left through the lateral structure upstream. Because we started with 40, we may have had some water leave through this lateral structure, and then we added another 20. So let's go ahead and take a look at the actual numbers and then record what this elevation is and what the freeboard is. To do that, I'm going to go up to View, Profile Summary Table. This is the max water surface elevation. It really shouldn't matter. All of the profiles, meaning all of the time steps, should be exactly the same, simply because it's a steady state and because I used a warm-up period. Yeah, so here we have it, 59.02. So what that tells me is 0.98 CMS of water left the system through that lateral structure. So we can take a look at that in just a moment. But what I want to look at here is the water surface elevation is 43.95. So I'm going to keep track in an Excel file over here. 43.95 is the water surface elevation when we released 40 CMS. And keep in mind that overbank elevation will be a constant of 45 meters. So the freeboard in this case would be the difference between 45 and the water surface elevation. That's 1.05 meters of freeboard. We can allow up to 0.55 more meters of freeboard. So what we want to do is increase that reservoir release to something higher. So instead of 40, let's go ahead and increase it to, how about 70? And we'll see what happens there. So let me just move that out of the way. And yeah, before we leave the results, I want to also check out the table for lateral structure. Here it is. And I don't have that particular reach selected. So let me click on reaches. And I want to open up River A Reach 1. I don't need River A Reach 2 because there's no lateral structures on that reach, and click OK. And then here are the results. And as you see, we have 0.98 CMS of flow leaving through the lateral structure. So upstream is 40, and then downstream is 39.02. All right, let's go ahead and modify our unsteady flow data file, which is not that one. And then let's change it to a constant 70 CMS instead of 40. So delete, delete, delete. This is where I could be creating a new file and a new plan, but like I said, we're just going to be overriding the existing data. File, save, close that, and then let's compute it once again. Okay, so that looks like it ran fine. Let's take a look at those results. First at the cross-section data. You can also click on this button right here to bring up the cross-section. We are at River A, Reach 2, Station 0. That looks good. So the water surface definitely increased because now we're up to a higher flow rate. It looks like we're still below 45. So yeah, it says 44.32 when I hover over, but let's look at the table data. View, summary profile, and then I want to go back to the standard one table here. And I needed to switch down to the reach of interest, which is actually, let's go ahead and add both reaches. So that's River A, Reach 1 and Reach 2, and click OK. This is the cross section of interest right down here, and we have a water surface elevation of 44.34. So we still have 0.16 meters of freeboard, so we could release a little bit more in flow if we wanted to, 44.34, and then I'll just copy that. We're down to 0.65 meters of freeboard, getting pretty close to 0.5. All right, so for our third iteration, let's increase the reservoir release a little bit more. How about 90 CMS? And then we can see what results we get with that. While we're here, let's go ahead and check out that lateral structure flow. We know it's going to be more than the previous iterations release. So let's go to standard table, lateral structure. Now with 70 CMS upstream, we have 5.58 CMS of flow leaving the lateral structure there at River Station 800. In fact, if I go back to the standard table 1, we have 70 CMS, 70 CMS. At the lateral structure, it drops down to 67, and then downstream of the lateral structure, it's 64. And then at River Station 400, where we have that tributary contributing another 20 CMS, it increases up to 84, and that's where it's held constant for the remainder of the reach. So this flow rate column right here is pretty interesting and helps me sort of summarize what's going on with this problem statement here. Okay, let's go ahead and do one more. Let's increase that reservoir release to 90 CMS. Go up to Edit, Unsteady Flow, and then double click on Flow Hydrograph. We're going to be changing the 70 to a 90, and then click OK. File, Save Unsteady Flow Data, Close, and then we can open up the Unsteady Flow Analysis, click on Compute, and looks like that finished up. So click Close. We can skip the cross section. I'm just going to go straight to the profile summary table. And now it looks like we have a water surface elevation of 44.56. So this is indeed above the allowable threshold, but it doesn't overtop the overbank either. I'm going to bring in my results here. So what did I say? We had 44.56. And then that's going to have a freeboard of 0.44 on the freeboard. So if I had to create another release, the answer would probably be between 70 and 90, probably a little bit closer to 90, so 85 perhaps. But I'm going to not do that. Go ahead and check it out for yourself if you wanted to do an exercise like this. What we did was we created a single river reach in 1D flow with an adjoining tributary, and we looked at the freeboard at this downstream location when our river reach happened to have a lateral structure with water leaving, a tributary with water entering, and then, of course, our decision variable, which was the amount of water we wanted to release from the upstream reservoir that enters the reach.